Hello everyone, welcome back to our next online class. In this class, we'll be dealing with our next chapter, that is analytical chemistry. Okay, in the last class, we were discussing about chemical bonding. Notes of the chapter chemical bonding, I will be publishing that in our website before next Tuesday. So please refer our website, write down the notes. No need to write the notes, it is enough if you are just keeping it with you, but try to answer all the homework questions. And in case of the notes, I won't be giving the entire notes for the chemical bonding chapter. The reason is most of the things that you have studied in this chapter, it was already there in your 9th syllabus. So whatever extra is there, whatever that is new in this chapter, I will be giving the notes for that only. So if you need more clarification, just refer your 9th class notebook or 9th class syllabus. Now moving to the next chapter, that is analytical chemistry. Before that, I have told I will take self-ionization of water. It is something that you are supposed to discuss when you are studying the electrolysis chapter. So it is better if you are discussing about that in electrolysis chapter. So we'll deal with that in the upcoming chapters. So we are directly moving to the fourth chapter, not the third one, fourth chapter, that is analytical chemistry. Okay, analytical chemistry, it is not just a simple chapter, it is actually a different branch of chemistry. As you know, there are many branches of chemistry like organic chemistry, inorganic chemistry, physical chemistry, and similarly there is one science, one field of chemistry, that is analytical chemistry. Okay, so all these branches, they are specific on their activities. For in case of analytical chemistry, their main aim is to analyze something that is given. Okay, so in other words, if you are giving something, they will analyze it and they will try to understand the chemistry of whatever that you are given. Okay, it is a branch that is esteemed for qualitative and quantitative analysis of chemical substance. In this chapter, there is not much about quantitative analysis. You are just finding some quality, or in other words, you are just finding what kind of for example, we can test whether certain ions are present in water or something. You have done a qualitative analysis in last year. I hope you remember your summer assignment. It was to check the quality of water, right? It is one of the topics that comes under analytical chemistry. So here in this chapter, we are supposed to discuss about some 5-6 cations. Okay, suppose you are given a compound. If one of the compound is containing any of the given cations in this chapter, how to analyze this? That is what we are going to discuss in this chapter. So what we are going to discuss here is the first thing. It is the color and appearance of different kind of metal compounds. The metal compound that you are going to discuss here in this chapter, the first one is calcium, copper, zinc, iron. There are two iron compounds. One is of Fe2 plus and other is Fe3 plus. That you will call you call that as ferrous and ferric ions. And at the end, we are having lead. So we will be dealing with 6 different type of cations and their compounds. First, we will identify their colors. And after that, the reaction with strong and weak bases. So what are strong bases? What are weak bases? Strong bases, they ionize completely when added to water. So examples of strong bases are almost all the alkalis. Almost all the alkalis, not entirely. Almost all the alkalis are strong bases. Example is NaOH, KOH, they are strong bases. Okay. Now weak bases, example is ammonium hydroxide. So what happened, why it is considered as strong base and weak base, that is something that you are supposed to study in the electrolysis chapter or acid, base and salt chapter. We'll go through that later, but still for your information, it is likewise. strong bases, they are having strong basic capacity, or in other words, it can attack even the weak acid. It can even react with almost all the compounds that bases are supposed to react with. But in case of weak bases, their reactivity is little bit lower. Or in other words, you can say it likewise. Strong bases, it will produce very high amount of OH minus ions. Weak bases, it will produce very low amount of OH minus ions. If you want a proper definition, it is likewise. Strong bases, it will ionize almost completely. Weak bases, they will ionize partially. Okay, now we will discuss with main cations that we are going to study. The first one is calcium, second one is copper. So what we are going to do here is, first thing, we will analyze the color of different compounds of the same cation. So for example, we will discuss calcium. We will take some compounds of calcium, we will check the color and appearance of calcium. Then after that, what we are going to do is, we will take a solution of the same compound. For example, not calcium, calcium 2 plus. The cation we are discussing is calcium 2 plus. So after that, what we are going to do is, we will take some compounds of calcium. For example, if I am taking calcium chloride, I will make a solution of calcium chloride in water. So after that, what I am going to do is, I will react it first with a strong base. So strong base that I will be taking here is NaOH, and I will check the reaction. Okay. After that, similarly, I will take the weak base and react with the same. So weak base here that I will be using here is NH4OH, and I will check the reaction. Okay, this is the criteria that we will be following for every cations that you are going to study in this chapter. So after adding NaOH and NH4OH, there is one more step. It is not like first we will take the solution and we will add NaOH. No, it is not like this. First we will take the salt solution. I will add 1 or 2 drops of the alkalis. I will check the change, or I will check the observation. After that, I will try to increase the amount of alkali, both the strong and weak, in different conditions. Okay, and I will analyze what is happening there. Okay. That's all for now. Now we will do this experiment in lab. We will discuss the observation by doing in the lab itself. Okay. Okay. So the first compound that we will be discussing here, it will be calcium. So I have taken 2 calcium compounds. The first one is calcium chloride, and the second one is calcium sulfate. So first we will analyze the color. Here, the calcium sulfate, it is little bit powdery. And what is the color of the salt? It is white in color. Okay, so calcium sulfate is white in color. Now I'll check for calcium chloride. So this one is a crystalline compound. Okay, so just check the name of this compound. Okay, now it is calcium chloride dihydrate. So I hope you remember what you have studied in your last year 9th class in the chapter water. So calcium chloride dihydrate means it is having a water of crystallization. Because of that reason, it is a crystal. Okay, that is why it is the structure of calcium chloride, it is crystalline. Unlike that of calcium sulfate, it is powdery. Okay. Now, other than that, you can see both the salts of calcium, they are white in color. So it is not just calcium sulfate and calcium chloride. Not almost, all the salts of calcium, they are either colorless or white in color. Okay. So if you are given a salt which is colorless or white in color, you can assume that it can be calcium. There is no guarantee that it will be calcium, but there is a possibility that calcium, if the salt is white or colorless in nature, the salt is calcium, because all the calcium salts are colorless or white. Okay. Now the next thing is, we'll take a test tube. This is actually a boiling tube, not a test tube. It is for your own observation only. Now I'll be taking little bit of the calcium chloride here. So, and I'll be adding I'll be dissolving the calcium chloride in water. Okay, I'm just dividing that solution into another boiling tube, and here I am taking the two alkalis. The first one, the little one, it is the ammonia solution. The larger one, the larger bottle, it contains NaOH solution. Okay, now to the first one, now I am going to add the strong alkali, that is NaOH. So first drop, so you can see in the first drop itself, it formed a white precipitate. If you wait for a while, this precipitate, it will settle down. Okay, now I am going to continue adding the NaOH solution. In some cases, when you are adding extra, there will be a different observation. Let's check whether there is any other observation if you are adding excess of NaOH. So it is forming more precipitate. I am going to add very much extra. So as you can see, it is a white precipitate. You can tell that it is a white precipitate. White chalky precipitate, that is also okay. So if you let it wait for a while, it will settle down. Just wait for a while, let it settle down. You can see the precipitate properly. Now it is like a white solution. After some time, it will settle down. You can see the precipitate properly. So here the observation is, when you are adding NaOH to calcium solution, we have taken calcium chloride solution. So if you add NaOH to calcium chloride solution, you can see a white precipitate that is formed. Even after adding excess of NaOH, there is no change. There is more precipitate formation, nothing else is there. So now we are going to continue the same experiment with calcium chloride solution and ammonia solution. So here earlier we used NaOH, which was a strong alkali. Here we are going to use ammonia solution, which is a weak base. Okay, now I am going to add ammonia solution. First I am going to add 1 or 2 drops. So I have added 1 or 2 drops. You can see there is no precipitate formation, no color change as in the previous case. Okay, now I am going to add further. So actually there is a slight color change, but there is no precipitate formation. Okay, so in case of ammonia, it doesn't react with calcium salt, or in other words, ammonia salt, they are not capable to react with calcium salt and to form precipitate. Okay, now we are going to discuss the reaction. Okay, the first reaction, it was calcium chloride CaCl2. It is reacting with NaOH. Okay, so you have already studied the double displacement reaction. So you can guess the product. Calcium, the chloride of calcium, it will be replaced by OH. So CaOH. Now OH is having -1, Ca is having +2 charge. So if you know the Christoph method, you can guess that it is calcium hydroxide. Okay, so now NH, Similarly, it will be exchanged with Cl. So other product is NaCl. Now the question is, what is the white precipitate that is formed here? As you know, NaCl, it is something that is soluble in water. If you need, you can just take some table salt and try to dissolve in water. Can you see any precipitate in water? No, right? If you are adding excess, there will be undissolved NaCl, but it is not a precipitate. Okay, so NaCl, it is not the white precipitate that you are seeing when you are adding calcium chloride into NaOH. So the precipitate that is formed here, it is a calcium hydroxide. So to indicate that it is the precipitate, you can put a downward arrow beside the calcium hydroxide. And I am going to write the color of the precipitate here. It is white chalky precipitate. Now I am going to write the reaction between calcium chloride and ammonia solution. CaCl2 plus ammonia solution. Ammonia solution, it means ammonia dissolved in water. So ammonia dissolved in water, it means ammonium hydroxide. NH4OH, it is called ammonia solution, or in other words, its actual name is ammonia hydroxide. It is also called as ammonia solution. Now, if it is reacting with the calcium chloride, you can see that there was no precipitate formation here, so no reaction. There is no reaction between calcium chloride and NH4OH. Suppose if there was a reaction, the product would be same, calcium hydroxide. It is supposed to give the white chalky precipitate, but in this case it was not giving any chalky white precipitate, so there is no reaction between calcium chloride and ammonia hydroxide. Now, okay, this was the two cases that we discussed before. This was the one with NaOH forming calcium hydroxide, the white chalky precipitate. The other one, it is clear solution with no reaction. It is the reaction between calcium chloride and ammonia solution. Okay, we are moving to the next cation, that is copper. Okay, first we discuss calcium, then we are going for the copper. Okay, so copper salts. First we are going to take, we are going to analyze the color of the copper salt. After that, we will take one of the samples and we will be dissolving that in water. So after that, just like the previous case, we will be adding first NaOH, then ammonium hydroxide. Okay, so first we are not going to add the entire ammonium hydroxide or entire NaOH. First we are going to add 1 or 2 drops, and after that we will try to add excess, and we will see whether there is any change. Okay, now here we are having 3 samples of copper salt. The first one, it is a copper sulfate. You have studied about copper sulfate in many classes. So the color of the copper sulfate, it is blue. Okay, there is another name for copper sulfate. It is called blue vitriol. So you can see from the color, blue vitriol, copper sulfate, it is having a very good blue color. Now the next one, it is copper oxide. Okay, the label is gone. So this one is copper oxide. So as you can see, the color of the copper oxide, it is black in color, black or brownish black in color. Okay, so there are not just in this chapter, there are many other chapters where you are going to study about copper oxide. Please remember the color of copper oxide. It is brownish black, or you can either write brown or black, any one, but it is compulsory either one of them. Okay. Now the last one, it is copper carbonate. So copper carbonate, it is green in color. Okay, so actually copper carbonate, it is supposed to have blue in color, but it is due to another impurity, that is copper chloride, that it is having this color. Okay, the copper carbonate, it will contain some impurities of copper chloride. Because of that reason, it will have the green color. Okay, so it means that the copper salt, it is not just having blue color. It is a salt which can have more than one color. So normally all the copper salts, they will have either one of these three colors, either blue, green. It is not entirely green, it is bluish green, blue, bluish green, or black. These are the three colors that is possible for copper. Other than that, you know about the metallic copper. It is having some brownish red shade. That is also possible. That is for metallic copper. Other than that, for all the copper compounds, these three are the only possible color: blue, bluish green, and the last one is black. So just like the previous case, we are going to take the sample. So I am going to take copper sulfate. Okay, so I have taken copper sulfate in a test tube and dissolving it in a little bit amount of water. So you will get a blue color solution. Copper sulfate is not that much highly soluble in water. Normally we use to heat it a little bit. So better. So I have dissolved the copper sulfate in water and I have taken in this test tube. So I am dividing it into two. Okay, so this is the first part. So to this first part, I am going to add the NaH solution. I am going to add 1 or 2 drops first. Okay, I have added 1 or 2 drops. If you can observe, there are little bit of precipitate formation here and there is a slight change in color. Okay, so earlier it was little bit bright blue, now it is like almost some greenish or pale blue. Okay, so it is actually a pale blue color precipitate. So what I am going to do is I am going to add NaOH further. I am going to add excess of NaOH. So you can see the precipitate formation, it is taking place further. Okay, so I am letting it keep for a while. Next, I am going to take the next sample. So here, instead of adding NaOH, I am supposed to add NH4OH. So I'll be adding 1 or 2 drops first. That is the first drop. So you can see here also there is a precipitate formation. I have taken little bit excess amount of copper. Reason I will tell later. Now I am going to add NH4OH in excess. So I am going to pour that into the beaker. Okay. So little bit more excess. And I am going to shake it. I am going to leave it for a while. No need. You can observe the change. Okay, this is the first one. This is the first test tube. That is a test tube with ammonium. This is the test tube with copper sulfate and NaOH solution. So the color and observation, it is a pale blue precipitate. Okay, so in case of NH4OH, with 1 or 2 drops, it formed the pale blue precipitate just likewise. But on excess, it formed a deep blue coloration. Okay, almost like some inky blue color. Okay, it is a deep blue color. It is a deep blue color solution. The precipitate, it is not there actually. So all the precipitate, it got dissolved and it formed something else to form this pale blue, deep blue coloration. Okay, but here in case of the reaction with copper sulfate and NaOH, it just formed the pale blue colorization. There is nothing afterwards. It just remain as in pale blue color itself. I hope this is understood. We'll go for the chemical reaction. Okay, so the first case that is in the this test tube, the reaction with copper and NaOH. Copper salt and NaOH. So CuSO4, that is the copper salt that we have taken here, it reacts with NaOH. So the reaction here it is same as the previous one itself. In case of copper chloride plus NaOH, it forms copper hydroxide plus NaCl. Almost a similar one. Since we are taking copper sulfate here, it will form copper hydroxide CuOH twice. This is a pale blue precipitate. Okay, so this pale blue precipitate, it is because of the copper hydroxide that is formed in this test tube. So all this pale blue precipitate, it is copper hydroxide. So there is also one more product. So as you can see, copper and OH, it form copper hydroxide. So Na and SO4, it will form sodium sulfate. Since SO4 is 2 minus in charge, so it will form Na2SO4. Okay. So this is the reaction that is taking place in the first test tube, forming pale blue colorization. Okay. Now we are going to discuss what is happening in the second test tube. In case of second test tube, first we are taking copper sulfate plus NaOH. Sorry, not NaOH. It is ammonia hydroxide, that is NH4OH, and the product here is copper hydroxide and ammonium sulfate. This is a pale blue precipitate. Do you think that I made a mistake here? Why there is a pale blue precipitate, we got deep blue colorization, right? No, actually after adding 1 or 2 drops, you got a pale blue precipitate just like the first case. But when we add excess amount of ammonium hydroxide, it got converted into deep blue colorization. Okay, so the pale blue precipitate that is formed with 1 or 2 drops of ammonium hydroxide, it is actually copper hydroxide, just like in the previous reaction. So why this deep blue colorization is formed from the pale blue color? That is what we are going to discuss here. The copper hydroxide that is formed here, it will react further with NH4OH. It will also take in some of the ammonium sulfate also, and it will form a new product that is soluble in water. Okay, as you can see, there is no precipitate, it is deep blue color solution. Okay, that means the pale blue precipitate, it is converted into, precipitate means something that is insoluble in water, right? That insoluble product, it is converted into something soluble. So the soluble product that is formed here, it is copper it is called something, it is the name of the product is copper tetraamine complex. Okay, so it is a different type of compound that you haven't studied yet. You are supposed to study this in your +2 classes. It is a product, it is a type of compound called metal complex. So it is a metal complex that is formed with copper and ammonium, not ammonium, with ammonia. This is NH3. Okay, the name of the product is copper tetraamine. Copper is here, tetraamine. Amine is another name of ammonia. Okay, so it is not another name of ammonia, it is used instead of word ammonia while naming metal complex compound. You will study that in the +1, +2 classes. So copper tetraamine means there are 4 ammonia here. For ammonia compound, it is reacting with copper to form copper tetramine complex. This square bracket, it is compulsory. You just study it by heart. As such, this is not something that is up to your syllabus for me to explain in the current situation. So copper tetramine complex, it is CuNH3 4 times, and it is having a 2 plus charge. It can be associated with the corresponding anions. For example, OH minus ion or SO4 ion. It can compromise this 2 plus charge. Instead of this 2 plus charge, you can write it as SO4 or OH minus. Whatever that is out of the both, it is not that much relevant in case of metal complex. So it is enough if you are just writing it as 2 plus charge. Okay. So this is a product, copper tetramine complex, and the color of this copper tetramine complex is deep blue. Okay. So that is all about this copper. Now before that, are you sure that this is what that is happened here? So just check the reaction. First, copper sulfate plus NaOH, it formed the copper hydroxide, right? Second is also it formed the copper hydroxide, but on excess of ammonium hydroxide, it formed the deep blue colorization. If you want to prove that, here in those who understood, just think about this. Else, those who don't understood it proper, just leave it as it. Now, here in the first and second case, the product is pale blue plus gray. This is the first product, that is copper hydroxide, CuOH twice. So if I am taking this copper hydroxide, this is the product that is formed when copper sulfate is reacting with NaOH, right? So instead of excess NaOH, if I have added NH4OH here, I am supposed to get the same product. So if I add more of NaOH, there is no change. It is still pale blue plus gray. So if I am adding NH4OH here, it is too dilute. Just wait a bit. Okay, I have removed excess. So I am adding. So it have started to turn back to deep blue colorization. Okay, the pale blue plus gray, it is turning to deep blue. Okay, so deep blue formation or this complex formation is glucose ammonia. Unless there is ammonia, it will remain as pale blue precipitate. If ammonia is present, it will get converted into deep blue colorization on excess addition of ammonium hydroxide. Okay, that's all for copper. Okay, the next compound that we are going to discuss, it is zinc or Isocyanates 2 plus cation, the compounds of Isocyanates 2 plus cation. So we are having two of the zinc compounds here. The first one, it is zinc sulfate, and the other one, it is zinc nitrate. So you can see the color. Zinc sulfate, it is a white crystalline solid. Okay, so in case of zinc nitrate, there is a little bit problem. You have studied about zinc nitrate in the last year. You can observe the reason here. It is actually, it is not water, but it is a deliquescent substance. What is a deliquescent substance? It absorbs the water and get converted into liquid. So it was actually salt inside, but since it was open, it absorbed a lot of water, it got converted into liquid state. Okay, since it is a deliquescent substance. Okay, so what we are going to do here, we are going to take some of the zinc nitrate. Okay, as you can observe, most of the precipitate, it got dissolved. Okay, Okay, I just remove a little bit from the test tubes. Now, as you can see, if you add excess of NaOH into zinc, if you add a little bit of NaOH to zinc, you can see white gelatinous precipitate. After that, if you are adding excess, the precipitate, it dissolves. Okay, you can say clear, almost a clear solution. So that means first it will form a white gelatinous precipitate. After adding excess of NaOH, it will turn to a clear solution, that is that white precipitate, white gelatinous precipitate, it dissolves after further addition of NaOH. Now we are going to do the same test with NH4OH solution. So I am going to add the first drop. Okay, I have added 1 or 2 drops. As you can see, there is some kind of precipitate formation. Okay, now next step, I am supposed to add it further. As you can see, the previous white gelatinous precipitate solution, it turned into colorless clear solution. Okay, so in case of zinc, whether it is NaOH or whether it is NH4OH, the observations are same. Okay, so on 1 or 2 drops, it will turn into white gelatinous precipitate. After adding excess of NaOH or NH4OH solution, the solution, it will turn the white gelatinous precipitate, it will dissolve in it will become soluble in the solution, or it will dissolve in the solution. We will get a clear solution after that. So we are going to discuss the reaction that is going to take place here. So the first one was, okay, I am taking zinc chloride for the reference, zinc chloride plus NaOH. Okay, so I first inform the white gelatinous precipitate. We are going to discuss what is that white gelatinous precipitate. It was the same as the previous case, zinc hydroxide. The first precipitate, the first precipitate with NaOH, that was for calcium, that white chalky precipitate, it was calcium hydroxide. The second one, it was for copper, pale blue precipitate, it was copper hydroxide. Now zinc hydroxide, that is white gelatinous precipitate, that is due to zinc hydroxide. So all the precipitates that you are going to study in this chapter, they are all hydroxide. Okay, so the precipitate is white gelatinous precipitate, it was zinc hydroxide. So other than that, the side product, it will be zinc hydroxide is formed here. So Na, it will be added with chlorine to form NaCl. That is a side product. Okay. Now this is a white gelatinous precipitate. So my question is, what happened when we add excess of NaOH? Why this white precipitate got dissolved? So the reason is the zinc hydroxide with excess of NaOH and in presence of NaCl, it will react further to form a compound that you have studied in last year and also in the 8th class. The compound is Na2ZnO2. Okay, the compound is sodium zincate, Na2ZnO2. This compound, it is highly soluble in water. So first, the product was zinc white gelatinous precipitate of zinc hydroxide, which was insoluble in water. When adding excess of NaOH, it react further to form another compound, that is sodium zincate, which was water soluble. Because of that reason, the white gelatinous precipitate that was formed first, it disappears after adding excess of NaOH. Okay. Okay, this is the case of zinc compounds reacting with that of NaOH. Now, in case of ammonium hydroxide solution also, the similar case appeared. First it formed white gelatinous precipitate, later it got dissolved after adding excess of NH4OH. We are going to discuss why it happened. So next one, it is the case for NH4OH. Okay, now the reaction between zinc chloride and ammonium hydroxide. First it formed the white gelatinous precipitate. So it was the same as the previous case. The product is zinc hydroxide, which gives the white gelatinous precipitate. Okay, now the side product is ammonium chloride. Now, what happened when we are adding excess of ammonium hydroxide to this white gelatinous precipitate? You observe that it got dissolved, just like the case of adding excess of NH4OH. We are going to discuss the reaction between zinc hydroxide and excess of ammonium hydroxide solution. So zinc hydroxide plus NH4OH, that is ammonium hydroxide, in excess, also in presence of ammonium chloride, it will form a compound much similar to another compound that we have discussed before. The compound is zinc tetraamine complex. Okay, so where have we discussed about this zinc tetraamine complex? Actually, we haven't discussed anything about the zinc tetraamine complex, but we have discussed something similar. That was this one. This one was copper tetraamine complex. Okay, so the copper tetraamine complex, the formula was CuNH3 4 times 2 plus. Okay, if you just replace the copper with zinc, you will get the same formula. Okay, so you don't have to consider the copper tetraamine complex here. So you just go through the zinc tetraamine complex. Unlike the copper tetraamine complex, the zinc tetraamine complex, it is colorless in nature. Okay, so zinc tetraamine complex, it is soluble in water, but it is colorless in nature. Because of that reason, when we are adding excess of NH4OH, this zinc hydroxide, it will react with ammonium hydroxide to form the zinc tetraamine complex, which was soluble in water. That is why the white gelatinous precipitate, it dissolved. Okay, so here we have discussed 3 cations today. The first one was calcium, the second one was copper, the third one was zinc. So we will just summarize it. The calcium, it reacted with NaOH to form white chalky precipitate. It doesn't react with NH4OH. So if you want to distinguish between NH4OH solution or NaOH solution, you can take a calcium solution and add, you can take calcium solution to a separate beaker or test tube, add to the one of the beaker, you add an NaOH solution, to the other add NH4OH solution. The one that gives the white precipitate, it is the one with NaOH. The one that doesn't give the white precipitate, it is the one with NH4OH. Similarly, in the case of copper, so we discussed that copper salt, they are having 3 different colors. The first one was blue, that is a common color for copper. Second one is bluish green, and the last one is black or brown color. So when we discuss the reaction with copper with NH4OH and NaOH, both of them, they form pale blue precipitate when we are adding 1 or 2 drops of NaOH or NH4OH. But the problem is, if you are adding excess of NaOH, there is no change. The pale blue precipitate, it will exist as such. But if you are adding excess of NH4OH, that is ammonium hydroxide, you can see the formation of ammonium the formation of copper tetraamine complex, which is deep blue in color. So to distinguish between NaH and NH4OH, you can again use a copper salt. Okay, so you don't know which one of this is NaOH or NH4OH. You just take two copper solution, any of the copper salt in two different containers. Take the solutions of both the copper salt, add the first sample to the first beaker, the second sample to the other, adding excess, not little bit. Okay, so after that you can see in one beaker it is pale blue color. That beaker, the solution that we add to that beaker, it will be the NaOH solution. The other one, it will be having the deep blue colorization, just likewise it will be the solution that you have added the ammonium hydroxide. So this will be a test to distinguish between NH4OH and NaOH. Now the last one that we have discussed, it is of the zinc. So if you are having the zinc salt, you cannot distinguish between NH4OH and NaOH, because the observation for the test of zinc with NaOH and NH4OH, it is the same. It means that if you are adding any of these two alkali, whether it is weak or strong, NH4OH or NH4OH or NaOH, first it will form a white gelatinous precipitate in 1 or 2 drops. After adding excess, it will turn its color to that white gelatinous precipitate, it will dissolve in that solution. And also the zinc salt, it is having white colors or white or colorless. They are white or colorless in nature. That's all what we have discussed today. So we'll discuss about the rest of cation. There are 3 more that are left. The next cation will be Fe2 plus and Fe3 plus, and after that we are having lead 2 plus ion also. Okay, we'll discuss about that in the next class. Okay, that's all for today. Thank you.